Hello there, Bear Cubs. Welcome to video number 90. This video is on parallel lines, and the key word that I've got for you is parallel. Now, when things are parallel, they will never meet. So when two lines are parallel, they will never cross. There will never be points of intersection. And I did mention that in the last video. The method states you will need to know the fact that lines that are parallel have the same gradient. Put that in big letters. The number in front of the x is what the gradient is. You should know that by now. And I've kept y equals mx plus c here for you. If you've been watching all my videos so far, you will know all of this. Using the fact and substitution of the x and y coordinate values into y equals mx plus c, you'll be able to solve to find the c value, and then you're going to sub that value, the m value and the c value, into the equation y equals mx plus c to get the equation of the line that is desired within the question. So in question number one, you've got to write the equation of a line that is parallel to the following three different equations. We've been given y equals 3x plus 4. Now, using that fact that it's got to have the same gradient, we can have y equals 3x, and then what do we put? We can put anything. We don't even have to put anything. We could just have y equals 3x if we wanted. But I'm going to put plus 5, right? Because that's just one more than this 4. Now that line, if I just do a little sketch for you, right, y equals 3x plus 4, let's say is there, right? There's 5, y equals 3x plus 5 is the line that is parallel to it. Okay, and that's a pretty poor sketch because it doesn't look exactly parallel, but those lines will never meet, all right? That's what we're talking about there. That's all it is. And we could have chosen any of the values, any number that we wanted at all, infinite number of numbers that we got to choose from. All right, and I was boring and I just chose the next number up from 4. In the second question, we've got the same thing. All right, we've got the gradient there is 12, so y equals 12 x and then minus 18. That doesn't matter at all that it's negative. I'm going to put plus 5. Okay, and when I teach this to people in real life, I kind of recommend that they just stick with a number, any number, and always use that same number, and you might forget what to do. Y equals 36 minus 5x. So this one, it's just the other way round. It's not, I showed you in exactly the same question in a different video in the y equals mx plus c one. It's just the other way around. So that's y equals minus 5x plus 36. All right, so we could write it that way around. It wouldn't matter, right? But I'm going to write it around the same way that they've done it. And I'm going to choose, you guessed it, 5 and then minus 5x. All right, and there we go. That is good enough for those marks. That's pretty simple stuff. But now we move up to the harder stuff, the grade 5 stuff. Right. Find the equation of the line that has the same gradient as y equals 4x plus 7 and passes through the origin. Now the origin is the point 0, 0. All right, so actually that's relatively simple if you know what the origin is, because it's going through the point 0, 0. And if you think about the sketch of that, if this is the sketch of y equals 4x plus 7, that's there, right? Well, we're going through there, the origin, right? And that, I don't really need to get rid of that, that will have no number on the end of the equation. It's just y equals 4x. It's got to have the same gradient, all right? And there you go. That's good enough. In B, you've got to find the equation of the line that has the same gradient as y minus 2x equals 8. So slightly more complicated because we've got to rearrange the equation here into the form of y equals mx plus c. And we've got a coordinate value passes through 0, 5. All right? Well, 0 is the x value, okay? And y is the 5, all right? Or 5 is the y value. All right? So if we're thinking about that, well, let's first of all rearrange this, all right? Let's put it in the right form. So y equals 2x plus 8, right? Now we know what the gradient is because it's in the form of y equals mx plus c, right? We know it's this positive 2 value. So we know it's got a positive gradient of 2, right? And we just need to know where it's going through the y-axis, all right? Where's the y-intercept value? So if that's y equals 2x plus 8, there's 8 up there, right? We're going 0, 5. It's got to go through 0, 5, and that's there, right? And there's our parallel line. So that is the y-intercept value of 5. If this x value is 0, that will be your y-intercept value, All right, so that's what you have to put in for your equation. Y equals 2x plus 5. All right, and I'd forgotten I'd put that question in there whilst I was using 5s in this first question over here. That is just a coincidence. All right, move myself over. Let's have a look at the last question. Find the equation of a line that's parallel to y equals minus 3x plus 2 and passes through the point 17, 18. Write your answer in the form of ax plus by equals c, where a, b, and c are integers. So, little comma in there. A, B, and C are integers. That means they're whole numbers, right? This is not in the form of y equals mx plus c, but I'll show you what you need to do there. I have already mentioned it in another video as well. But let's look at the equation here. We've got a negative gradient going on. It's going for a positive y-intercept value. It's got to go through these this particular point. So this isn't 0, 5. So we have to use this method, all right? And this is the only one really where we are using that method. Everything else is a little bit simpler. So let's write out the what we do know about the equation of our line that we're trying to find. Y equals 3x plus c. All right, we know that. We don't know what this value is. We know it's not plus 2, right? Because that's the equation of the original line. All right, and we're going to put in 17 and 18. So that's our x value, and that's our y value. We're going to put them in the right places. Right, and it's very easy to mix those up. 18 is the y value. Label them like I have, and then you won't make the mistake. So 18 equals minus 3 multiplied by 17 plus c, right? Well, let's do that calculation. Minus 3 multiplied by 17 is minus 51 plus c, and 18 is still on that side. And we're solving it now to find our value of c, all right? So following the steps in the method, add the 51 to both sides. That will give us 69 is equal to c, and we found our c value that we can put in to the equation here, right? We can write the equation out now as y equals minus 3x plus c, right? That's not quite the end of it because we've got to write it in this format. Ax, that's just a number in front of x plus a number in front of y, is equal to c, all right? So all we've got to do is move over the x term from being negative onto the other side of the equation, and that's going to give us the answer of 3x plus 1y, which we don't write the 1 for, and then equals, why did I put c up there? I found c, 69, right? Idiot. Right, let me start that bit again. Y equals minus 3x plus 69 is the equation, right? Because I found c and I popped it in, right? Even though I didn't, but I have done now, right? There you go, there's the equation. Move the 3x over onto the side. 3x plus y is equal to the 69 that is on this side on its own. All right, and there is our equation in that particular format. All right, pretty tricky last question, but hopefully you're going to navigate those okay in the future. It's literally a case of substitution. There's a lot of substitution involved in the graphs topic and in algebra just in general. So get good at being a substitution wizard. All right, and if you are a substitution wizard, let me know in the comments, and what I'll do is I'll make some substitution wizard badges. I'll design them myself. I'll get them made myself. I'll pay for them out of my own money, and then I'll somehow, I don't know how, but somehow I might be able to get one to you. I actually don't know how I can do that. That's an empty promise, isn't it? But there we go. That's it. There's your video on parallel lines. It's good to know. All right. Thanks very much for watching this one. Like, subscribe, continue to practice, and be a wonderful human. Take care. Goodbye. Farewell.